Hello, we're back, and this time we're doing Unit 7, Section 1. We're back doing inverses. From inverses, back a couple chapters ago, is the reflection across the y equals x line. And we're going to talk a lot about this. Yada yada. So we have the x squared, the quadratic function, and here I just sketched the graph. This function passed the horizontal line test. Well, the horizontal line test is when you get a horizontal line going across the graph, and it fails the horizontal line test because it crosses the horizontal line test. It crosses the horizontal line in 2 points, here and here, and then here, here, and here, here. So that's why we say, no, the horizontal line passes through the graph twice. This means its inverse is not a function. And we're going to work on this a little bit more. Think about what the inverse would look like. So we have this right here, and then we have the y equals x line is right there. And if you were to reflect this x squared graph over here across this line, it would look like something like this. So its inverse is not a function. So what could be done to the function so that it would pass the horizontal line test? Well, restrict the domain. We could use only half of the parabola right there. So we could use only the part from 0 toward positive infinity, or when x is greater than or equal to 0. Then it would pass the horizontal line test. How does that relate to the range of the function? Well, the domain of the original function is the range of its inverse. And we will have more examples that will talk about this, but this is the core, this is the main thing. Okay, so the domain of the original function is going to be the range of its inverse. Okay, so x and y switch. And we talked about how x and y switch when we're doing the inverse, the process of finding the inverse. So when you're trying to find f to the power of -1, that's the notation to find the inverse. Okay, so we're trying to find the inverse of x squared. So we know algebraically how to switch x and y and then solve for y. And then every time we take the square root, it's plus or minus. However, with the domain restriction that we talked about here in this case, we're only going to use the part where x is greater than 0 or going from 0 toward positive infinity. We're only using half of that parabola. Okay? So with the domain restriction, then the inverse is just simply square root of x. Okay, this is algebraically, and this is how the graph would look like if you were to graph. This is the y equals x line, and we know the x squared is a reflection over that y equals x line right there. So does f -1 of x pass the vertical line test? Yes, the inverse is a function with a domain restriction, only with the domain restriction. What is the domain of f -1 of x? The domain is 0 to infinity inclusive, okay? It is the range of the original f of x, and it is needed domain restriction. So, conclusion, to find the inverse function of a square function, a domain restriction is needed that is based off the range of the original. So that's why we can do what we know what to do, but you just need to restrict the domain right there on the original, and then that would restrict the range on there. Okay, so now we're talking about cubic function. Did this function pass the horizontal line test? This one is yes. So if I were to trace a horizontal line right there on the graph, it only crosses the horizontal line once everywhere. And that's what it says right there. So what does it mean compared to what we discovered in the previous page? Well, this means the inverse is a function. So if I were to find the inverse of this function, it would also be a function because x doesn't repeat. So off we go trying to find the inverse of a cubic function. So we're going to do it algebraically, and then we're going to answer the questions right here. So we're trying to find the inverse of the cubic function. We switch x and y, and then we solve for y. So we cube root both sides. That should be a cube right there. Cube root both sides. Okay, therefore, the inverse of a cubic function is a cube root function, and it looks like this. This is different than this, and this is a reflection of this one across the y equals x line. This is the y equals x line. Okay. Does f negative 1 of x pass the vertical line test? Yes, the inverse is a function. Bam, right there. What is the domain? So the domain, which is good because we already know the domain of a cubic function is everything from negative infinity to positive infinity. So, and it's also on a cube root is also from negative infinity to positive infinity. And that is the range of the original. So if I am trying to find the domain of the inverse, I can just find the range of its original and voila. But you know, you can just find the domain of based off the graph. It's fine. So conclusion, for the cubic function, there is no domain restriction. So we like that because the inverse is already a function. So that's nice. So here for cubic functions, a domain restriction is not required. For the inverse, since the function passes the horizontal line test. So we like that. However, for squared functions, like a quadratic function, a domain restriction is needed for the inverse since the function fails the horizontal line test. The domain restriction for the inverse is based off the range of the original function, because the domain of f of x must equal the range of its inverse, and the range of f of x must equal the domain of f negative 1 of x. The domain and range switched.